My name's David Watts. I'm an ITS engineer at Transport for Greater Manchester. I've worked there for about 3.5, 4 years. I was saying before, working in a sort of public sector environment, your role can change a lot depending where the priorities are. Obviously, we've got a mayor now, so again, priorities have shifted. What I hope to do today is mainly highlight the wealth of data that we're currently collecting and maybe give a different perspective from a data provider and also a bit of an end user perspective as well. So just a brief summary of the slides. I don't need to go into too much detail on the importance of data today. You know, working in a public sector organisation has really helped me understand the value in the data. Everything, as I'm sure you're already aware, requires that level of justification. Not only to quantify and analyse, but to influence changes on our network too. Got a quote there about the concept of big data. Again, I know I don't need to go into too much detail on that, but in a world where we've got an ever-increasing bulk of data, we could sometimes get lost in some of that noise, and we need to be able to harness this data and use it to answer some of the questions and find solutions. So just a bit of background on Transport for Greater Manchester. It covers the whole Greater Manchester region, not just the city region. Some people aren't always aware of. Similar to TfL, but we don't have the same legislative powers or the London-centric transport funding that we have in this country. Not that I'm bitter or anything. Overall aim is making travel easier, which again fits in line with today's workshop. With this in mind, there was a transport strategy published in 2040, and this placed the use of data and technology at the centre of this. I will go into that in a bit more detail later. Greater Manchester then, it's the fastest growing city outside of London. Projected population increase of well over 3 million by the time that 2040 reaches us. Yeah, you can all read that for yourself. This 2040 strategy is a public-facing document, so you are welcome to download it and have a read. It's a bit of a meaty document, and it's not the most enthralling read, but there are parts of it that are very interesting. The use of data and technology is central to this, and it really does help understand how all this will take place, achieve some of that ambition that's in there. So as I said at the start, I'm an ITS engineer. Bit of a vague job description, get involved in all sorts of exciting things at TFGM. Primarily, my role is to find intelligent solutions that help make travel easier. And a key part of this is the provision of data, useful data, and also providing access to other users as well, which we'll go into. So moving on, just hope to give a bit of a flavour of the data collection that does take place at TFGM. When I first started, it was primarily part of the local Sustainable Transport Fund. See the Bluetooth passive sensors there. My role at that point was very much more hands-on in the installation and commissioning of these assets. There's a big rollout. Around 2014, 2015, we've now got over 750 of these sensors up and running, collecting live data. The way it works is you've got a sensor at point A, point B, collects a randomised MAC address, and you get a journey time from it. We use that data in a variety of ways. We'll go into more detail later. It's actually used live in our control centre and has been for a couple of years now. But is also used for all sorts of levels of analysis, scheme justification, that sort of thing. Traffic signal data, I know we touched on it earlier. Scoot, we've got quite a large Scoot network across Greater Manchester. I think 900,000 or so sites or nodes. Again, I won't go into too much detail. There is a a level of AI associated with that. It automatically adapts to changes in the traffic flow, etc. However, it's worth pointing out there are limitations with that. I myself, along with a team of engineers, undertake something called network monitoring, where in an AM peak or PM peak, we actively monitor the network using this data, CCTV cameras, etc. Make changes on network. One of the most common things I do is make changes to the Scoop model. For example, a vehicle breaks down, there's a lane closure, roadworks, that sort of thing. We have to intervene at that point, doesn't pick that up automatically. I would say about 90% of my time network monitoring is doing that sort of thing. Can that be automated? That would be great. Your old school loop in the road traffic sensors. These permanent sites just in the top right of the screen there, we've got about 150 so of them. By no means new technology, but what I will say, we do also use them in a live environment as well, and they report back to our database every 5 minutes. Really good in an operational sense, that give a live indication of what's happening on the network. Also used for giving to our guys in the modelling team to help them use for all sorts of transport models. We do actually have a growing network of cycle counters. Those of you who are familiar with Manchester's policy, there's a bit of a shift towards cycling, this multimodal share. Chris Boardman's the new cycling and walking commissioner, and there's a growing estate of cycle sensors as well, which really useful to get a picture of what's actually going on in terms of cycle uptake. Car park data, again, not new technology. We have our own estate of car park counting technology, as well as getting a data set from third-party providers, NCP, etc. Air quality, again, a political hot topic. We're in the short time I've been at TFG, we've trialled all sorts of different air quality sensors. In terms of validation, we're not quite happy with everything yet, but we're getting there. We've got a growing estate from a number of different suppliers, and again, this is another valuable data set that can link in with some of our other data sets to perhaps make some valuable interventions. This isn't everything. I've put a question mark there because it is a growing number. As a large public sector organisation, we're getting proposals all the time from organisations who want to work with us and provide us with more data. Very challenging. It's not just as simple as that. It needs to be in the right format, etc., which we'll come on to later. There's another data set we're currently getting at the moment. We have a small estate of 3 weigh motion sensors, not yet used for enforcement, but we've had some liaison with Greater Manchester Police about these. Basically what we've been doing is sort of highlighting repeat offenders, so we can look at the DVLA database and look at vehicles at companies who are repeatedly going over the weight limit, and there's another conversation that needs to be had at how that is enforced. At the minute we're using advisory letters, that sort of thing, but there's an ongoing conversation about how these may be used for enforcement in future. What we'll touch on is just how some of this data is stored and analysed from an end user perspective. UTC, as I mentioned before, we've got a large Scoop network. This helps store all the traffic signal timings, etc. There is an element of human developed strategies within this, and as I said before, during this network monitoring, we perform this active intervention. You've got Astrid there as well. I think it was developed by University of Southampton, which does help store and profile this data as well. C2, this is something I've been quite heavily involved in my time at Transport for Greater Manchester. Mainly used to host our Bluetooth journey time data. The map you see is how it's presented sort of to the end user, to our control centre. Kind of looks a bit like a Google traffic map, but we actually have ownership and more control of the data. We can go into it to a more granular level. It does integrate with other systems, which again we'll go into more detail with. one thing I will say about that is I am happy to provide access to anyone who wants that data at the end, so just let me know. I know some of you have been in touch with my colleague already about that, but yeah. Atom. Now, this was a system procured, I think, 2013-14, actually went live in 2015. It was certainly not a new idea, common database. TFGM have had loads of different ones over the years. This was an idea trying to consolidate them a bit and bring everything together, and certainly bring a new sort of operational look at this as well. I know, Damien, you mentioned before about sort of developing a playbook for operators. This is something we've tried to do with the Atom system, in that it brings in all these data sources, our own third party, etc., integrates that all together, and it is actually sort of a strategy engine that we've used. We have actually called it a playbook for our operators to intervene in certain scenarios. It is data driven, so it takes into account sort of the Bluetooth journey data that I've talked about earlier. And it can be linked with other assets as well. I've just tried to give a bit of an indication on the screen there of how it looks from an operator's perspective. Again, like C2, I'm happy to provide access to the system. Restricted access, of course, can't have you changing traffic lights and stuff. But yeah, come see me at the end, I'll be happy to sort that out too. Recent developments, future ideas. So, in an ever-changing world, we have to ensure that data we collect is valuable and is still important for use. A good example of this is the Bluetooth journey time sensors, which, you know, there's been a big expansion of our network, but now recent studies have shown that the sample size of data that's collecting is actually decreasing. So I think at one stage it took into account about 20% of vehicles, quite a good sample size to understand journey times. That's actually decreasing at the moment to closer to 10%. Number of reasons for it. One of them is Bluetooth technology has changed slightly, so it doesn't detect the latest iPhone Bluetooth. Other devices have been recognised as well. We've been informed by the supplier that they can get around this, but they haven't as of yet. But that's just a good example of how we need to continue to think about using this new technology. A way of addressing that Bluetooth issue was we did a trial with access to Google data. We did have access to raw data, but we also got it to talk to our Atom system as well, which we used for a validation exercise against our Bluetooth data, just to sort of compare accuracy. Bluetooth compared quite favourably, although I think Google was a bit more responsive in that it worked better in a live environment. But again, it was useful to see, is that the way we might go in future? Who knows? It's very expensive if you wanted to buy it. So there's that commercial element as well we need to think of. Now, if you don't mind, I'm hoping to introduce Mark Nicholson at this point, the CEO and founder of Vivacity, just to talk a little bit more about an upcoming project we've got.
We've started off by creating video analytics powered sensors, so using AI actually onboard a sensor in order to gather data about what's happening within the road ecosystem. You can see an example there, or I think actually David's previous slide has sort of one of our very standard examples of just looking at the different types of data that we can collect from a video-based sensor. You compare this to an induction loop, which is obviously the standard today. You can see how there's a huge amount more information coming out in terms of vehicle positionings, vehicle types, vehicle behaviours, and movement patterns over time. So that's kind of step one for us. Step two was then all about prediction, so looking at how we can use AI to forecast what will happen next. And then stage three is all about optimization, which is linking much more closely to some of the work of the Turing Institute that was talked about earlier today. So I just wanted to come on to what that actually means from our perspective and what the focus of this project that I mentioned is. So it's a £3.5 million project focused around Manchester, part funded by Innovate UK. And the goal is to, I suppose, revolutionise the way that some of the traditional systems, so Scoot and Mover that we've talked about quite extensively already today, and to fix some of the flaws with those. So I suppose one is to incorporate class information, so being able to make everything multimodal as opposed to just how many vehicles are going past. Two, we've already heard from David about how challenging it is to set up and maintain these systems. That's something which, say, Manchester and London have the budget to do, but actually a lot of smaller authorities kind of start to struggle with setting up and maintaining these kinds of systems. And three is around optimization. Scoot and Mover were designed back in the 80s and 90s. They were fantastic for their time, but AI has the capability, as was discussed by Ben earlier, to explore a much wider optimization space. So we're, over the course of the next couple of years on this project, looking to really explore how can we do things better from an AI perspective to solve some of these challenges. So this is using reinforcement learning, using simulations to iterate through hundreds of thousands of times, working closely with Robin from Immense, and then deploying in the real world in Manchester. So we're looking at an area of, I think it's about 20 junctions in Manchester to deploy towards the end of the project to really prove that this is not just a theoretical capability, but it actually works in real life. So as a result of that, we'll have multimodal optimization, which is self-optimized, so no need for the sort of manual expert input, and it's all based on AI, so the level of optimal control that you can get to should be much, much greater. So that's kind of all I wanted to say. Was just a very brief introduction to that project, but feel free to catch me or one of my two colleagues, give us a wave, over there afterwards if you want to chat more about it. Thanks very much.
Yeah, so you heard from Mark there about you know, an upcoming project they're looking to work on. Another example of a sort of a new type technology I've been working on, these are Wi-Fi sensors working in a similar way to our Bluetooth network. This was used to sort of detect pedestrian movements across the city centre. Again, that's an ongoing trial at the moment. Conscious of time here, so I'll just skip to the last slide. Sorry, air quality. Just to really highlight some of the challenges that are faced by myself and colleagues in the organisation, but what I also feel are opportunities as well of how we can work together to sort of address some of these as well. As Mark sort of highlighted, the maintenance and the operation of these assets is, you know, really time-consuming and costly. Got 2,500 traffic signals, over 2,000 other intelligent assets. Certainly, from a personal point of view, it takes up the bulk of my time dealing with all the different suppliers, diagnosing faults, manage it. You know, it can be really difficult. It's not just as simple as providing a data set. Data format and quality, as you've seen, we've got an ever-increasing wealth of data, but it's important that this needs to be in the right format. For example, using the Atom system is good, but it's often very costly and timely process getting the data in there. You know, it's sometimes not even worth the cost of the project, the cost of integrating a data set to be used, which is a real shame. In that sense, it's collaboration is necessary. I mean, even internally, the challenges I face at TFGM can be difficult. I mean, just using that Red Ninja as an example, I think we contributed something like £2,000 to the scheme, but our own internal IS was wanting to charge 20 grand to utilise the broadband lines at traffic signals, so it was nearly a year waiting to get communications there because there was no way we were going to find that sort of funding for a small trial, and that really is like a barrier. So we're trying these new things and looking again at open data. Worth mentioning that our Atom system does publish a number of these data feeds to the TFGM Open Data Portal, which is free to subscribe to if anyone would like to do so. There's a number of data sets in that which I can discuss with you in more detail if you'd like. But again, as was alluded to earlier, there's certainly a challenge in publishing them as open data. You know, there's a big cost associated with that and often a privacy issue as well. So yeah, that's pretty much it. Happy to answer any questions you might have.